Hello guys, welcome to the presentation. This is Keyang Yu and I'm going to present for the final project. Our project is the distributed home monitoring system. Basically we're starting with the system design. Our system is basically can semi-separated into three parts: the Raspberry Pi part and the database and also the data visualization. So first we're going to connect the sensors to the Raspberry Pi and read the serial data from the GPIO slots. And then we're going to first decode the data and send them through the socket connection from the Raspberry Pi to the Windows. And on the Windows, we're going to retrieve the data first and then insert them into a database. So we have a MySQL database for saving the data. And then we're going to visualize those data through a chart.js. And we plot the temperature and the humidity data and the lines chart on the web page. And also we can do the temperature and humidity data forecasting through the machine learning algorithms. So here is the data flow diagram. So basically we have a Raspberry Pi acting as the master. We have several sensors. We have the temperature and humidity sensor. We have the motion sensor. All of these sensors are connected to the GPIO slots. And then once we receive the data from the sensors, we're first using the serial decoder to decode those sensors and to decode those data and transmit them into the socket client. And then we send the data through the socket client to a Java program as the socket server, and it will receive the data and send them into the MySQL database. And we're going to do the web page rendering, so they pick the data from the MySQL database. And for here, we have one Raspberry Pi as the master node, and it's easily to copy and add more Raspberry Pi as the slave nodes, and all of them are sending data to the master nodes and then do the socket transmission. So we were going to introduce the Raspberry Pi first. So the first is the sensor management as well as the data transmission. So basically we have two sensors, the DHT11, which is a humidity and the temperature sensor. And also we have a SR501, which is a motion sensor based on infrared. So here is how we connect the sensors onto the Raspberry Pi. So note that here, this graph, we are using the breadboard. We connect to the sensors to the breadboard, and then we connect them into the Raspberry Pi. But in the demo, which we are going to show you later, we have the sensor directly connected to the Raspberry Pi. So this is basically due to that we want to lower the resistance from the wire and also from the breadboard, because higher resistance may cause run data reading. So basically, here on the graph on the right shows the data shows the GPIO slots. So we have the motion sensor connected to GPIO5, which is the pin 29. And also we have the DHT11 connected to GPIO21, which is the pin 40. So first we introduce the motion sensor. As we said, it's an infrared motion sensor. And it has three pins. The left one, the green wire connected to the left one is the VCC. So it should have a 5-volt VCC. And the middle wire, which is a blue wire, connected to the data, and the right one connected to the ground. So for this sensor, it will send a high voltage to the GPIO slot if it detected motion, and it will send no data through the GPIO slot if there's no motion detected. And the data format is year, month, date, hour, minute, second, and is motion or no motion. And about the temperature sensor, which is a DHT11, so it also has three pins. The 5 voltage or 3 voltage is both well, and it has the middle wire as the data and the right one as the ground. So different from the high or low voltage simply. So the temperature sensor will send a 40-digit binary number. So once receive the request from the host, so this 40-digit binary number shows the humidity and the temperature. So here is the datasheet, a part of the datasheet for the DHT11. So basically, we can see through the line here. The first thing is that the MCU, which is the host, will draw down the voltage, so it sends out the start signal, and then it will pull up and wait for a sensor for the response. So this will hold for at least 18 milliseconds. And then the sensor will draw down the voltage to send out that it received the response for the signal. And also it will going to pull up the voltage and get ready for the sensor's output. So once the data was drawing down, it started the output data. The first 8-bit is the humidity integer part, and the second 8-bit is the decimal part of the humidity, and similarly as the temperature. And also we have an 8-bit decimal 8-bit checksum. So once the transmission is completed, the resistor will pull up the bus's voltage for the next transmission. So this graph shows how we handle this kind of data, how handle this voltage pulse. So we will first sleep, and then we will set the output, set up the output, and then we are going to set the input, and then after the first settings, we're going to start sending the data. We'll first send the signal from the MCU to the sensor, and then we wait for the response from the sensor. So for the data decoding, we can see here is a sample here. We have the humidity integer, humidity decimal, temperature integer, and temperature decimal. As well, we have a checksum. So also we on the code here, we just separate the data into by 8 digit, and we are going to do a binary to decimal transmission, and changes them into readable data. And for the checksum errors, we have found that we are having multiple checksum errors because it just looks like this. The sum of the received data is 304, but the checksum is 177, which means that this kind of data has violated the checksum rule, and we have to discard it. So the reason is mainly because that this kind of wire connection have some unstable pull-up resistor, which will have the lower pull-up voltage as we require, and in this case, it may cause some run because the voltage, since it's in an analog circuit, the change of voltage, the voltage changes may easily be flip-flopped. And once we finish the transmission, finish the decoding, we are going to transmit the data through the Raspberry Pi to the Windows machine. So here we have the Pi as a client and the Windows as a host, and we are sending the data through port 2048. And we have the data format showing here. So we also, when we send the data, we're also going to print the data on the Raspberry Pi side. So we can see that this data, if this data is correctly inserted into the database. So for the host machine, we're going to introduce the data transmission about the receiving part, and also we'll introduce the database and also some part of the machine learning prediction. So here we have the Java program, and the Java program are listening to the socket and also insert the information into the database. So the hosts are listening to port 2048, but you can see that in the screenshot is 6666. So basically, it's due to some weird reason, the 66 are already occupied in my other computer, so we have to forcibly change the port number. And here we also use the comma as separator to pick the data from the string. And we also need to match the time format. So here is the table properties. We have the ID, which is the auto increment primary key. And we have the temperature and humidity, both are integers. And we also have the timestamp in a datetime format. So for inserting the data into the database, we are using the placeholder instead of the connecting strings, instead of using multiple inserts. So this is basically used to avoid SQL injection attack. Yes. So we are going to determine the data format on each placeholder. So basically, the data format are integer, and the date time. So once we inserted the data successfully into the database, we'll print a successfully inserted. So here is the table's overview. You can see that we have multiple temperature information, humidity information, as well as the timestamp information. So the ID, temp, and humidity are all of them are integers, and we have the date time as the format for timestamp. So for here, the timestamp recorded by the Raspberry Pi are its local time, and it's already converted into the UTC time and then store them into the database. And for the machine learning prediction, we have the SVM with different kernels. Also, we have decision tree, k-means, and random forest. So basically, we're going to cluster the temperature and the humidity information into different clusters. And about the forecasting, what we mainly do is that we just detect if the forecasted information are higher, are extremely higher or lower than the previous one, which means it may change into another cluster. So in this case, we're going to trigger a notification. And for the web page rendering, we're going to introduce the chart.js, which is the model we used. And we're going to introduce the data fetching and also the page designing. So basically, chart.js is an open source library to visualize the data through the JavaScript. It can have the bars, lines, or pies, and all of them can be responsive. So, and also it can be automatically refreshed through the MySQL database. So here we use the PHP method to fetch the dataset from the designated MySQL table. So first we connect them to the MySQL database, and we select all the information from the table, and then we are going to handle them into the page. So we have the page designing is an auto refreshing per 3 seconds to reflect the changes in the database, and also we set the chart mode as the line chart. So we are using the timestamp as a shared x-axis, and we show the timestamp, and we show the row 1 and 2 as a separated y-axis, which is the temperature and the humidity, and we have the pink line as the temperature and blue line as the humidity. So here is basically how the result looks like. All right, and I'm going to show the demo. Hello guys, so this is a simple demo for the final project of TCN6270. So the project is a distributed home monitoring system. So we will introduce the hardware first. So we have a Raspberry Pi 3, and we have a temperature sensor DHT11, and also we have a motion sensor SR HC501. So these two sensors are both connected to the GPIO slots on the Raspberry Pi. And we first introduced the motion sensor. The green wire are connected to the 5 voltage, and the blue wire is the data, and the purple wire are connected to the ground. So for the DHT11, we also have 3 wires. The white one, the left one, are connected to the VCC. It could be 3.3 volt and also 5 volt. And the gray one, the middle one, are connected to the data, and the purple one is the ground. So we will first show the a simple demonstration for the motion sensor part. So this is a infrared motion sensor. So if it detects some hands before it, it will show the motion. So apart from the Raspberry Pi, since it's a distributed system, we also have the database and also have other codes running on the on a Windows computer. So we will first run the motion sensor part on the Raspberry Pi. So simply we just run Python motion sensor.py. Yes. So the default output is no motion, and if we put hand before it, like this, it should yeah, in this case it should give us is motion. Well, it's not that, I guess it's not really, yeah. So it's starting to output the is motion, and if we remove our hand, it will come back to the no motion mode. Yes. So it's really simple. So it's just the motion sensor detection, and also we will have the we're going to run the temperature sensor. So basically, we are going to, since we have a socket connection to the Windows computer, we will need to start the server first. So we first start the Java program on the Windows computer, and you can see it's already started right now. And then we run the Python tempSensor.py, and it will show linked. So in this case, the temp sensor already linked to the computer and started inserting data. So similarly, it will also have the data inserting and successfully inserted. So as we already introduced in the presentation, so according to the wires and also the improper grounded Raspberry Pi, we will have very much wrong readings, like this kind of inaccurate data. Also, the temperature 13 degree and humidity 158%, these are all wrong. So, but also we have a correct data here, 24 degrees and humidity 63%. So similarly, we were going to, so now we're going to show the MySQL database part. So basically, the database is built in this format. We have the ID, which is the main key. It will automatically increase. And also we have the temperature, humidity, and the timestamp. So as we continue refreshing the database, we are going to see that, for example, we have 136 routes here. And if we refresh it, we will see that it's continuing, it's adding more data into the database. And so sadly, we cannot show the web page right now because we have some technical issues. We cannot run the PHP code properly. So here is the only way we can see it through the database. So we cannot see the data visualization part. So basically that's it. We have a motion sensor and we have a temperature sensor and we can read their data. So that's all for the demo.